Welcome to Math 106, Chapter 3.1, where we talk about some more derivative rules. So these ones are pretty straightforward, and we'll learn another one in our next section. But let's go ahead and get a hang of what's called the product and the quotient rule. So right off the bat, it does tell us the product rule. So you'll notice that it's trying to take the derivative of two separate functions that are being multiplied together. In doing so, they have made an equation for us for your derivative rule. It just says that we are going to go ahead and take the first derivative of f of x. So we'll derive f of x, leaving g of x alone. Then we're going to add it to just f of x. And now we get to take the derivative of g of x. So they kind of take turns taking the derivative, while the other one just gets to remain alone. And that's also written down here as well. So it just says, again, the derivative of the product of two functions is the first function times the derivative of the second, plus the second function times the derivative of the first. You'll notice that I wrote it backwards here because of rules of addition. It doesn't matter which one you complete first, other than make sure you are just taking taking turns deriving each. And again, it says, it walks you through it down here with the notation. So it says the operation forming the derivative f prime of x from the function f of x is also indicated as the symbol d over dx. This is just another way to say the derivative with respects to x. Thus, they have two forms that you might be seeing. So if you see d over dx of f of x, that is just asking for your first derivative. And you can see that down here. And again, here, and once more here. And you'll also notice over here, it says verifying the product rule. It shows us that the product rule works for cases of f of x is equal to x squared and g of x is equal to x cubed. If we were to go ahead and multiply the two, then it's x to the fifth. And if we were to do them separately, right? If we were to derive it all together, great, this is what it is. But if we were to take turns deriving and then multiplying, add, derive, and multiply, we still end up with the same exact answer. Now, in some rules, you may want to go ahead and multiply it, because it's not so bad if you multiply these two in FOIL, but in the future, you will see things that are much more complicated. In doing so, let's start off with something super simple. So if we were to say, okay, what is my f of x function, right? What are my two functions being multiplied? Well, f of x, we could just say is this first parentheses. Therefore, my second parentheses could be my g of x. And if we're trying to take turns deriving, let's go ahead and set it up here. Can you go ahead and take your first derivative of x and then again of g? Well, we would get 6x squared minus 5, and then we just get 3. Now, when we put it together, when we do f of x times g of x, and we take your product rule, again, this is called your product rule. It's called your product rule because we are multiplying these two together. So when we go to derive, we're just going to take the derivative of your first function, multiply it by just your second function, plus your first function, underived, multiplied it by your second function derived. So take your first derivative of f, 6x squared minus 5, and multiply it to g, 3x plus 1, plus take f, 2x cubed minus 5x, and multiply it by your 3. And that is all we are doing here. It just says, okay, take this first function, and we see that over here and here, And then it just says take this first derivative, and we're going to see that right here, and multiply it to your g. G here, and then your first derivative of g. So this is kind of just the placement of all of your values. Now it does come in handy if you do kind of write this rule a few times. That way it kind of sinks in. We're going to get some practice with that today. So now let's go ahead and try example 2 and have you guys practice. And again, this notation, dy over dx, that is just saying the y here is in response to this y. So if it said just f of x, or if it just didn't say anything, you could have just this d over dx here. So it just says, can you go ahead and derive? So let's see what you come up with here. It says f of x perhaps is, again, that first parentheses. And g of x can be the second parentheses. Now, I'm not sure why your textbook does it this way, because these are just from your textbooks. But when we go ahead and do the performance of both derivatives of f and g, notice that we have the power. And if I said, hey, this is really maybe just x to the fourth, what would you derive that as? Well, it would be derived as 4x cubed. However, our x is in the place of this whole thing here. So instead of deriving the inside first, what we're going to learn again in our next lecture is something called the chain rule. Again, I'm not sure why your textbook introduces it so early, but the chain rule says, let's go ahead and do this power rule first. So we bring down the 4, leaving behind everything that's in the parentheses, and change your exponent. Now let's go ahead, now that we've taken care of this power, let's go ahead and derive the inside. Kind of like it's a treasure chest. You have to unlock the treasure chest, and then you can go ahead and open the lid. That's exactly what we're doing here. The treasure's on the inside. We now have to go ahead and unlock it, and then we can open the lid. So now let's go ahead and derive the inside of just 2x. Let's have you guys try it again with g of x. First, that power rule. And again, I'll show you that here. Bring that down. 5. Come on. 5. X squared plus 1. That's now to the power of 4. So you've just unlocked the treasure chest. And now we can go ahead and derive the inside. 2x. And again, this 2x is just happening because it is the derivative of that inside function. Now let's go ahead and bring your product rule together. Again, I'm just going to rewrite this part. Copy. I'm going to paste it here. And I'll get rid of this part. There we go. All right, so let's bring it together. Let's go ahead and grab your f prime. So that would be this whole function here. If you do want to clean it up, I would suggest actually doing it here. 8x times x squared minus 1 cubed. 10x times 10x times x squared plus 1 to the 4th. So let's go ahead and grab f prime of x. 8x x squared minus 1 cubed. Let's multiply it to g, x squared plus 1 to the 5th. Now let's go ahead and add. Take your f of x this time, x squared minus 1 to the 4th. Now let's go ahead and grab g prime. So that would be this value down here, 10x times x squared plus 1 to the 4th. Now I might do just a little bit of arranging. Well, first, let me go ahead and kind of highlight where these have come from. That way you can easily see where everything is. So this is all from that first derivative of f, g of x being right here. Then we're taking your f being right here, and then multiplying it to your g prime. All right there. So now let's go ahead and clean it up. So this part can stay the same. There's not much to it. The second one, though, I might want to rearrange just ever so slightly to have my GCF out front. And there you go. Now, I do want you guys to start to factor out what they have in common. So this isn't your final answer. Instead, let's go ahead and take a look as to what these two terms have in common. So see if you can pause the video. Now, one easy thing to see that they have in common is that they have how many of these x squares minus 1 in common? Well, they have 3 of them in common. The other one has 4. So we can take out 3 of these x squared minus 1 all the way out. And again, this will just be 1 less. 1 left. Now let's go ahead and see what else they have in common. Well, they have an x squared plus 1 in common, and they have 4 exactly in common, again, leaving 1 behind. Have 4 of them. And lastly, they not only have 1 x in common, but they do have a 2 in common. So we can take out a 2 and an x. That's a 2 and a 4, a 2 and a 5. So they both have that little 2 in common. So they will leave behind all together from your first term, they left behind a 4 and 1 of these x squareds plus 1. From your second term, they left behind a 5 and 1 of these x squares minus 1. Now let's go ahead and simplify your inside. 2x, x squared minus 1 cubed, x squared plus 1 to the 4th. And on the inside, we have 4x squared plus 4 plus 5x squared minus 5. And go ahead and one more time, simplify. So the outside remains the same. The inside, however, we can go ahead and add your x squared terms together. We can go ahead and subtract your inside, your two constants together. And now this one, unfortunately, has to keep going one more time because this one is the difference of 2 perfect squares. So one more time. Now, on a test, it obviously will not be this long. However, I do want to make it known that I will ask you guys to simplify. So take out as much as you can and then bring out the leftover bits. So this would be, in fact, your final answer. I do apologize that this one was so long. Again, you're not going to see this degree on your test. Most likely, if you see it, maybe I would have put this to the first degree and maybe not had so much to it. Now, there are some worksheets to this with videos, so please, if this part is throwing you off with the product rule, please watch the following videos on just trying to get some practice. So this is the product rule. Let's go ahead and try the quotient rule. So with the quotient rule, quotient saying things are being divided, and you'll notice that we have d over dx. That notation is just saying, hey, take the derivative of two values or two functions that are being divided, in which case we are going to see the following equation. We're going to take the first derivative of x times g of x. We're going to then subtract f of x times its derivative of g of x divided by g of x all squared. And I'm actually going to put that in yellow because that part gets easily missed. And again, this is just a shortcut to it. Instead of actually going ahead and dividing these two and making it so complicated, it just allows us for a shortcut. So let's go ahead, and you'll notice the placement of your f of x and your g of x. Notice that g of x is doing the dividing, so it is going to be the below function. So let's go ahead and break them up like last time. What would our f of x be in this case? F of x is your numerator, so it's just x. Now, can you go ahead and take the first derivative? Well, that would just be itself 1. Do the same with g of x. Take the derivative, it's just 2. Now let's go ahead and put it into this equation. So we have the quotient rule. Which just says, okay, if we have f of x over g of x, we're going to take f prime of x, multiply it to g of x, minus f of x times g prime of x, divided by g of x all squared. So let's go ahead and grab your first derivative. That would be 1 times g of x, 2x plus 3, minus your f of x here, x, times your derivative of g of x. Divide that by g prime of x, or sorry, g of x, and then we're going to square it. Square. Now let's go ahead and, well, I'll highlight for a second, and then let's go ahead and start to simplify. Now I want to highlight just as the same ones as before. So that's my f. This is my f prime. My g is green. And then I have a lighter blue right here. There we go. Oh, and I also missed one. I want to make sure that's in orange. There we go. Now let's go ahead and simplify just a smidge. So we have 2x plus 3 minus 2x all over 2x plus 3 squared. Keep it going. You'll notice that these two will cancel. So we're left with 3 over 2x plus 3 squared. And that would be our final answer. Now, again, if these two rules are hard, please watch the next video with the practice worksheet where we start out pretty basic, and then we're going to get progressively harder as we go. And then our next video in chapter 2 or 3.2, we'll talk all about this chain rule here that you're kind of seeing here. It's kind of like a domino effect, like the chain effect, where you have to derive something first, and then you derive the inside, and then you kind of just trickle down.